At this station, we're going to be studying transpiration. Transpiration is the movement of water throughout the plant that is powered by evaporation. Water moves through plants from the roots to the leaves through the xylem. The xylem is made up of hollow, modified plant cells that are joined together to form a pipeline of sorts. As water moves up the xylem and to individual cells, it will evaporate. The unique chemical properties of water, like hydrogen bonding, and the force of evaporation will draw even more water up through the plant. You can think of the force of evaporation like what happens when you apply suction to the top of a straw. It will draw fluid all the way from the bottom to the top. Just like many biological processes, transpiration is affected by environmental factors like temperature and humidity. Temperature affects the rate of transpiration in two ways. First, when the air is warm, water molecules are going to move faster, and thus the rate of evaporation and transpiration will be faster. In addition, the water holding capacity of warm air is higher than cool air. Humidity can also affect transpiration. If there is already a lot of water in the air won't be able to hold much more, and thus evaporation and transpiration will be low. However, dry air will have a much higher holding capacity for water, which will speed up evaporation and transpiration. I am going to conduct a demonstration so we can view transpiration in two different plants. The main goal is simply to view the transpiration occurring, but with two different plants, we can also hypothesize about their rates of transpiration as well. Typically, plants with large, broad leaves have higher rates of transpiration as evaporation is occurring in the leaves. Our Egyptian starflower here has smaller leaves than our painted leaf begonia here. However, the Egyptian starflower has more leaves and typically does very well in environments with a high level of moisture. This may indicate that it has a high rate of transpiration. So I'm going to water 3 of each of these different types of plants and take an initial mass measurement. Then I'm going to seal them inside a plastic bag and put them outside in the sun. Every hour for 3 hours, I'm going to check on them and take an additional mass measurement. If transpiration is occurring, we should see their mass decrease as water is going to evaporate. I would like to note that some of the mass decrease we may see could be from water evaporating directly from the soil. However, this should not account for the entire decrease that we may see in the mass. Make sure you record your hypothesis on your handout before we get started. Do you think the rate of transpiration will be the same for both of these plants? Or do you think one plant will have a slightly higher rate of transpiration than the other? Record that, and then after the demonstration has ended, we'll discuss why we may have seen the differences that we saw. Okay, so we're ready to get started on our demonstration. We have our 6 plants on the right-hand side, all labeled, and I'm going to water them with approximately 100 milliliters each. You'll see there are 6 beakers in the sink. Those are all filled with, again, approximately 100 milliliters of water. I'm going to water each of the plants and then let them sit for 5 minutes so that water can drain through and make sure the soil is saturated but not oversaturated. So after that 5 minutes, then I'm going to record the mass of each of the plants, and that will go on your data sheet under time 0 or the initial mass. Now that each plant has been watered, I'm going to let them sit for 5 minutes and then we'll come back to take the mass.
5 minutes later.
For the sake of consistency, I'm going to be taking the mass of these plants in the same order that I watered them. So we'll start with number 5, then 2, 4, 3, 1, and 6. And remember, you'll want to record this on your data sheet. So let's take the mass of plant 5. The mass for plant 5 is 220.62 grams. Plant 2 is 314.68 grams. Plant 4 is 252.04 grams. Plant 3 is 318.76 grams. Plant 1 is 336.53 grams. And lastly, plant 6 is 249.30 grams. Now it's time to put all of our plants inside the plastic bags. Those plastic bags will give us a closed environment so we can really get an idea of the rate of transpiration in all of these plants. All right, now that all of our plants are inside the bag, we are ready to take them outside and put them in a sunny spot. Let's go. Okay, so all of our plants are outside and I've alternated them. So we have one of each type of different plant next to each other. The reason for that is it's possible that the left side is slightly sunnier or warmer than the right side. Hopefully that will take away those biases. Now, of course, this is just a demonstration. If we were doing a true scientific experiment that we wanted to publish results for, we need a more specific methodology and measurements, as well as a higher number of plants or a higher replication. But hopefully we'll see some interesting results from our demonstration today. So I'm going to come back to these plants in an hour to take the second mass.
1 hour later.
Okay, it's now been an hour, so I'm going to take the plants out of the bags and weigh each one. To make it easier for me, I'm not going to film this process, but I will take a picture so we can have that to look at.
One hour later.
Okay, we are back outside. 2 hours have now passed, and I'm about to start taking the mass for all of our plants.
One hour later.
Okay, 3 hours has now passed, so I'm about to take our third and final mass for each of our plants. To conclude, we saw the mass decrease as time progressed, which means both of our plants were transpiring. If you haven't already, record your data and perform the calculations. First, you'll want to determine the overall change in mass for each plant. To do this, subtract the final mass at time 180 from the initial mass at time 0. Then you're going to want to find the average change in mass for each plant type. So you'll want one average for the first 3 plants and a second average for plants 4 through 6. After calculating, you should see one type of plant had a slightly higher rate of respiration than the other type. Before we started this experiment, or demonstration, you recorded a hypothesis. Was your hypothesis supported or refuted? Why do you think that might be? Hopefully this demonstration helped you learn a little bit more about transpiration.